Assalamualaikum. My name is Norisham, a final year student enrolled in degree of Mechanical Engineering. Here today to present to you regarding my final year project proposal, supervised by Associate Prof. Dr. Aida Jumaat, entitled Modeling and Simulation of Open Hole Tension Behavior of Synthetic and Natural Fiber Composite Laminates. So this is my table of contents as referred earlier from draft proposal submitted to my supervisor. We started off from project backgrounds and the objective of this project. The second one is the problem statement. The third one is the literature review, where past research articles such as journals, books, and the pre-journals, etc. The next one, we covered the scope of this book. The fifth one, we covered the methodology, where procedure of this project will be reviewed. The next one is the preliminary result, where expected result is being presented. Regarding the project background of this final project, two types of fiber which will be incorporated into composite laminates includes synthetic and natural fiber. Synthetic fiber can be defined as man-made artificial fibers engineered in laboratory, while natural fiber can be found in the nature, such as plants and animals. The examples of synthetic fiber used in engineering industries include carbon fiber, glass fiber, and Kevlar, while for natural fiber, which can be found in the nature, includes knaf, jute, hemp, and flax. For this project, we will cover the study of stress analysis, which includes the tensile strength. Tensile stress is a quantity associated with stretching of tensile force, and it is responsible for the elongation of material along the axis of the applied load. Since nowadays the engineering studies are focusing on building and using materials that have advantage of high strength to weight ratio, thus by utilizing the fiber reinforced polymer composite materials, those preferences are achievable. The main objective of this final project includes number one, to evaluate the effect of fiber types on tensile and open hole tension behavior of fiber epoxy composite laminates. As illustrated earlier, we will cover the study of tensile strength upon the open hole of natural and synthetic fiber. The synthetic fiber includes carbon fiber, glass fiber, and Kevlar fiber. As for the natural fiber, it is include knaf, jute, hemp, and flax. For the second objective of this project, we wish to determine the effect of layer sequence on tensile and open hole tension behavior of fiber epoxy composite laminates. The fiber ply orientation for this project or layer sequence, which will be implemented to this final project, is from 0 degree, 90 degree, plus minus 45 degrees. The reasons this final project is executed is number one, in industries, fibers are utilized and bonded to other materials via bonding fasteners such as screws, rivet, nut and bolt, etc. The open hole structure of these composite laminates leave gaps in fiber, therefore tension shall arise. The second part of the reason includes the natural and synthetic fiber type effects needed further engagement on the tensile strength of notch and open hole fiber composite laminates. For the literature review parts of this final project, there are 5 types of studies based on past research articles, journals, books, etc. These articles related to the title of this final year project, which is the study of tensile strength of open hole of natural and synthetic fiber composite laminates. For the first one, Hu et al. Discovered that the unidirectional array chop strands enhance the mechanical properties, particularly tensile strength, which is greater compared to the conventional short fiber reinforced polymer, while ensuring outstanding flowability. The result gathered for notch unidirectional array chop strand laminate was measured at 298 megapascal, which is about 60% of the strength of the notch unidirectional array chop strand laminate. Based on the result and plot graph provided in Hu et al. Studies, it's found that the stress-strain relationship of notch unidirectional chop strand fractured at 0.7% strain in the region of 300 megapascal stress applied upon sample, compared to the notch USCS, which is elongates further at 1.08% strain when applied to 500 megapascal stress. It should be noted that the tensile strength of a specimen decreases as the mesh number increases. For the second part, McBride et al. Discovered that the alteration of layup sequence hugely impacted the resultant tensile strength and the formation of glass fiber composite. The investigation of glass fiber yielded unidirectional glass fiber exhibiting the stiffest behavior compared to other layup configuration, which only elongates about 2.46% strains when applied with 474 megapascal tensile force, while steel fiber composite laminate yields about 4.5% strains at only 161 megapascal. As for Marom et al. Discovered hybrid effect from layup sequence arrangement as deviation of mechanical properties from rule of mixture. The fourth literature review discovered from Green et al., which studied the tensile strength of open-hole composite laminates of different fiber ply orientations. Green et al. Utilized a unidirectional and quasi-isotropic carbon fiber laminates with stacking sequence of 90 degrees, -45 degrees, and 0 degrees as specimens to carry out the investigation and obtain data of different values of tensile strength and failure mechanism. The fiber stacking sequence used in Emilda et al. Are configured to unidirectional notch, unidirectional open hole, and open hole which fibers placed parallel to principal stress direction. This study is virtually materialized via Python software simulation where finite element model is created. This is one of the example illustration for meshing and modeling of open-hole fiber composite laminates, where the fiber stacking sequence can be decided or arranged, and the specimen is followed by ASTM, or the American Standard for Testing Method. Another example of illustration of open-hole fiber composite laminate. This is the increasing number of meshing from element number 15,000 up until 500,000 above. There are 4 scopes of work regarding this final year project, which includes first the implication of open notch and open hole structure effect on tensile strength of composite laminates. The second one is the fiber type, which will be focused on, as mentioned earlier, both natural and synthetic fiber. The third one is the utilization of ANSYS software to do the modeling and simulation of open hole tension behavior of natural and synthetic fiber. The last one is the orientation, which we focus on the fiber pipe orientation. As suggested by the supervisor, the orientation which will be implemented is 0, 90 degree, plus and minus 45 degrees. A linear procedure for the methodology of this final project is being implemented. First, we started from defined objective and problem statement, as mentioned earlier, up until literature review, data gathering and parameter setting, 3D models of hole and hole laminates with various fiber types and stacking sequence. This is being explained earlier, where we'll be implementing natural and synthetic fibers upon the study of tensile strength of open hole, and the stacking sequence is set to 0, 90 degree and plus minus 45 degrees as suggested by the supervisor. Next is the 3D simulation, where ANSYS software will be utilized, and finally we'll be finish off with the thesis writing. This is the preliminary result as found and referred from the past research article, where the deformation is illustrated from the minimum, which is in blue color, and the maximum, which is in red color. The deformation value can be founded from the DMX, which is equal to 0.00589 mm. The expected result from this final year project includes 1. The tensile and open hole tension behavior of fiber epoxy composite laminates depends on the fiber types. It is expected that the synthetic fibers composites have higher tensile strength of notch and notch samples when compared to those of natural fiber composite materials. Second one, the tensile strength of notch and notch samples of synthetic and natural fiber composite depends on the laying sequence. It is expected that the unidirectional laminates will exhibit the highest tensile strength when compared to the 45 degrees and 90 degrees fiber directions laminates. In conclusion, I would like to thank my supervisor, Associate Prof. Dr. Aida Jumahat, and my fellow students for helping and guiding me towards completing this draft proposal of FYP01. Thank you. And if you have any further inquiries, you can reach me by my emails as shown. That's all. Thank you.